solar modulation of the jet streams and polar vortices. We will be expanding on the lessons from parts 1 and 2 on the plasma particle influence and their path to the atmosphere. The goal here is to provide 2 macro-scale facts from the peer-reviewed literature, some sources that you can pause the video and jot down if you need to dive deeper, and then show the mechanisms behind these atmospheric modulations. The first key fact is that solar minimum brings more jet stream blocking. Solar maximum brings fewer of such events, and jet stream blocking is how you get considerable exacerbation of drought or flooding, and how you go from 10 degrees above average one day to major storms that night, and 10 degrees below average in the days that follow. Solar minimum also brings more polar vortex weakening events. Solar maximum brings far fewer. And for most parts of the world, the weaker the vortex, the worse the winter cold will be. One of the major exceptions to that is Australia, which tends to see hotter and drier conditions due to where the southern vortex tends to kink. Now, in terms of how the sun does these two things, we're going to go through these items here and describe how they work. First, up top, we do indeed see about a 10 meters per second difference in the upper jet speed between sunspot maximum and sunspot minimum, with the jets being faster in the maximum. Now, while the jets are not quite up at the ionospheric level, there is a vastly greater interaction and coupling with the D region of the ionosphere and much greater access to the sunlight and solar particles, especially than, say, at ground level. And one contributing factor is indeed the increased ionization and heating of the upper atmosphere by solar flares, which of course are much more common in sunspot maximum. The second point notes that high solar activity also pushes the jets towards the poles, all while expanding the Walker cells. Now we're going to hold on to why regarding the jets moving towards the poles and look at the Walker circulation, which is an equatorial beltway, which involves El Nino and La Nina, which by the way are also shown to be heavily influenced by solar activity, and the expansion of these Walker equatorial cells due to solar heating is really one of the keys to all of this jet and vortex forcing. Because in the third point, we see that the Hadley cells are not only expanded like the Walker cells, but they too are pushed poleward in terms of the other atmospheric cells. So there's no way to put the Walker circulation on here too, except for plugging this little overlay on. And this is what's causing the rotation to also spin in the Hadley cells in that vortex, helix, spiral shape around the globe as opposed to spinning in space. So picture the Walker circulation with the Hadley cells there in the equatorial region. And now look at the sunlight exposure, the CME compression exposure of the magnetic field, where the Van Allen belt electrons are pushed into the atmosphere, and compare what's going to happen at the tropics to the rest of the world. It's no wonder we see the primary expansion of those tropical cells and circulations when the sun is giving them more to work with, which naturally pushes the jets towards the poles as the cells expand, since the jets ride between the Hadley and Ferrel and polar cells. And so yes, when the equatorial cells are puffed up and the jets themselves are getting more energy, they are faster and tighter and pushed away from the equator to hold the polar air firmly at the polar region. Those events where you get snow coming down to the southern parts of the Gulf states doesn't happen without the jet stream or polar vortex, or likely both, being too weak, too wobbly, and failing to confine the polar air, as the equatorial cells are likely deflating and allowing everything else to come towards the equator and sunspot minimum. With the polar vortex, there is also that forcing of the direct particle interactions from the magnetic field, which does couple particles directly to that region, which is also why Australia is one of the oddballs in weak polar vortex events as they get heat and drought. The South Magnetic Pole is actually near them as it has left Antarctica, and so the vortex tends to dip the other direction away from them. If it seems like the how of the solar energizing, heating, and expanding of those equatorial cells was somewhat undercovered in this episode 3, there's a good chance you missed the first two regarding cloud microphysics, sunlight access, and particle forcing by Joule heating, among other mechanisms. Both of those examinations are linked below this video. In case you missed them, they will be very helpful for this one. And so to review, that solar forcing takes its most effect at the equator, at least in terms of large-scale cells in the atmosphere, Walker and Hadley, more than the Ferrel and polar cells. The cell expansion at the tropics pushes the jets and other cells towards the poles, where their more energetic state at sunspot maximum is now in a better position to confine the polar air and avoid the jet stream blocking that creates the weather extremes. It really is that simple, and yet its understanding in academic terms is still relatively new. It will be a major factor in climate science moving into the future. We've got more coming in this series, and whenever you're watching this, I'll be here in the morning for the daily update. Be safe, everyone.